Hi, my name is Fran Chalmers and I'm going to be talking to you today about the last line of defence, which is considering PSVs during inspections and also a little bit of losing long shots from the blue line. So PSVs are a risk mitigation measure to prevent the serious injury from the hazard of stored energy or pressure as a result of a failure of a pressure system or one of its component parts, and they're often referred to as the last line of defence. As it turns out, are ice hockey goalkeepers. So first of all, I'm going to speak to you about one of the 100 greatest NHL players in history and Canadian legend, Johnny Bower. Johnny Bower was a Toronto Maple Leafs goalkeeper known as the China Wall. And back in his day, as you can see, they didn't wear any protective masks. So quite a brave guy. He played until about the age of 45 and he eventually gave up because he was starting to lose long shots from the blue line as his eyesight was starting to fail. He was self-taught during the Depression on the ponds of Saskatchewan, and his great hero at the time was a guy called Frank Brimsek of the Boston Bruins, known as Mr. Zero for his excellent goalkeeping record. And Johnny always wanted to be Mr. Zero, and I think that's something that resonates with all of us as we aim to achieve zero accidents incidents. So, our PSVs, much like our ice hockey goalkeepers, need to be set up for success, unlike this poor guy. I'm going to move on and just speak briefly about the pressure system safety regulations, covering the safe design and use of pressure systems. Now, whilst these apply onshore, they're often used as examples of good practice for us offshore. So first of all, we have safe operating limits. This is defining our IOWs. We have our written schemes of examination, telling us the frequency and type and nature of examination that we're going to do. We have the examination in accordance with the written scheme. So this also includes the preparation for inspection and also reporting and considering items as fit for continued service. We have action in case of imminent danger. So our response to anything on the plant that would cause us imminent danger. We've got operations, which covers both operation procedures during normal operations and an emergency. We have maintenance, keeping our items of equipment in good order for use. The keeping of records, this includes things like the design basis, our P&IDs and our inspection records, as well as the precautions to prevent overpressurization. Now, when we think about PSVs, every plant item which can exceed its safe operating limit needs to be protected by at least one pressure relieving device here. And that needs to be suitable for the intended duty of that vessel and also as close as practicable to the piece of equipment that it's designed to protect. So they require periodic examination by a competent person. And that is typically done in the offshore environment by PSV contractors, often removing PSVs, sending them back on shore for testing and recertification during shutdown periods. But for our inspectors, considering the inspection of the vessel, at the end of the examination, they need to be satisfied that the protective devices are set correctly and operating correctly. And if we go to the likes of API 510, for the inspection of pressure vessels, the pressure relieving devices should be inspected at intervals that are suitable to verify that devices perform reliably and in their particular service conditions. So what does the testing and recertification look like? So here we've got the test rig. When the PSV comes to a test to be tested, it's tested at the cold differential test pressure. This is the pressure that's modified for the service conditions of back pressure or temperature versus the set pressure in service. And they'll pre-pop test this unless it's particularly fouled or dirty, in which case they would need to reduce their inspection frequency of them. And they'll test this up to 90% of the cold differential test pressure. If it fails before then, this is considered a soft failure. So this is a pressure relieving device that would have relieved too soon. They'll continue up then to 110% of the cold differential test pressure. And at that point, the test is usually stopped because it's considered a hard failure, as in the PSV wouldn't have lifted. It will then be stripped, inspected and maintained, so that will be the removal of gaskets and O-rings and replacement of those. It will then be tested again and certified with its next test date and a test certificate, and it will also be leak tested to API 527. So in terms of when our inspectors are going out on the plant to inspect a vessel with an associated safety valve, first of all, they're going to check with the tag against the PSV register. And they're going to confirm that they've got the POP testing records, the certification dates, any findings. This could be things like corrosion, deposits or blockages that have been found in the PSV. That would go on the inspection report. And it's also good practice here to report any instances of persistent PSVs lifting in the plant. We then go out onto the plant. And so our inspector is going to record the external condition of the valve, checking for any damage, corroded casings, that sort of thing. They're also going to be checking to identify if there have been any mechanical damage or modifications, anything that might restrict correct operation. And then importantly, confirm that any upstream valves that are required to be locked open are locked open. And then they will also check the associated pipework and supports to make sure they're not broken or displaced. And they do all this because they need to endorse the vessel or piping as fit for continued service. So if they have any doubt about the fitness of service of the PSV protecting it, they can't then say that the vessel or piping is fit for service. Now, the reason that I'm talking about this today is in our recent UCAS surveillance visits under our ISO 17020 accreditation, we've been asked, what do we do around PSVs? And so we've explained that we check the certification, we do the visual inspection, we record this all on our inspection reports. And then recently we were able to give our assessor an example of one of these things. So there was a PSV where the test recertification date was later than that was recorded for in the work management system. And so we had gone back to the operations team and asked why that was, find out. And it took them some time to come back to us. And our assessor felt that we hadn't really escalated this very well with our client. So we had a little bit of a discussion internally about how we would escalate this with our client. What would be the correct way to go about this to ensure that we got a speedy and appropriate response to queries around our PSVs, which obviously are essential for safety. So we thought about our anomaly categories, and I'm sure you'll be quite familiar with this type of thing. Under our system, the prioritisation ones, we have our yellow superficial anomalies. They don't present an immediate threat to the system, and then they don't need immediate repair. We have our orange or accessible anomalies. Whilst they don't immediately present an imminent danger to the system, they will eventually, if they're not addressed, then they may lead to failure. And then we have our critical anomalies, which is anything that represents imminent danger. So I don't know what you would think about what level of categorisation you would feel is appropriate for if you had a query around the PSV's suitability. We thought about the criteria and we felt they came into two categories. One is the assurance check to ensure that the testing and recertification is within date, and then also around the operation of the PSV. So we came up with three criteria. One is that it's beyond its recertification date, and of course we felt this was a critical anomaly. Our second one was a discrepancy between our maintenance management system, i.e. when the next testing was planned, and what the test certificates say or the PSV registers say. And then finally, the visual condition of the PSV. So this was any mechanical damage, modifications. This could be locked open valves that were closed. Again, would be critical anomalies. And why is this important? Because endorsing a pressure vessel for fit for service, where we're not confident that the PSV can protect us from serious injury, just can't be done. Because we need our protective devices to work when they're called upon, much like our ice hockey goalkeepers. because they're the last line of defence. Thank you.